Hello, wonderful viewers. Welcome back to our class. This is the third class or the third lesson we are having on partial differential equation. The first one we talked about the introduction, definition, how to find the order, the degree, the dependent and independent variable of partial differential equation, then how to form a partial differential equation. So in the second video, we talked about solution of partial differential equation by direct integration. So in this particular one now, we're going to be talking about the three analytic method of solving partial differential equation. And the first one is what? The Euler's method of separating variables. The second one is what? The Laplace transformation method. And then the last one is what? By integral method. We're going to be using the three of them. So let us start with the first one. So let's start with the first one. So for this first one, we have an example. Just an example will show you everything, then you are good to go. So we're asked to solve 3 partial u partial x plus 2 partial u partial y is equal to 0. Okay, we are asked to solve this. Now, anytime you are given something like this, look at what you do. It's very simple. Solution, you tell them let that dependent variable be equal to what? X of x and y of y, like this. Okay, capital letter X of x and capital letter X of y. So if you have that partial y partial t, so what do you tell them? And then you have partial y again partial x. So what do you tell them? That your y will now be equal to what? Capital letter T of t, and then what? Multiply by what? Capital letter X of x. So that is that. As simple as that. So that is what we do. So now, from here, let us now differentiate with respect to x so that we can get this one. So differentiating with respect to x, I'm going to have, differentiating with respect to x, I have partial u partial x will now be equal to. Now, this is like a constant. Differentiation of x is gone. Okay? So, sorry, this is a function. So differentiating this will give you, this is like a constant. So you leave it. We are leaving the constant, which is capital letter y of y. Okay? Differentiating this, I'm going to have partial x over partial x, like this. Okay? So now, the next one is to differentiate with respect to y. If we differentiate with respect to y, we are going to have partial u partial y will now be, this one will now be a constant. So you leave the constant, then differentiate this to give you what? Partial y over what? Partial y, like this. So now, substitute the two of them in equation 1. Let me call this equation 1. Substitute the two of them in equation 1. You're going to have 3, instead of writing partial u partial x, we'll write it as what? Y of y partial x plus 2. Instead of writing this one, I'll write what? X of x, then partial y over partial y is equal to 0. Okay? So let's take this one to this side. We are trying to separate. Let us separate. So separating, we're going to take this one to this side. So I'm going to have 3y, okay, partial x is equal to what? Is equal to minus 2x partial y. Now, we are separating. So we want all the x to be at one side and all the y to be at one side. So multiply both sides by xy so that we can do that. So multiply both sides by xy. If you multiply by xy, I'm going to have or divide both sides by xy, sorry. So divide both sides by xy, or this x will just come down here, the y will go down here for you to separate, as simple as that. Or you divide both sides by xy, any of them. So I'm going to have 3 over x, okay? If this one is coming down, is equal to minus 2 over this one will come down, y. Okay, sorry, I'm having my partial x over partial x is equal to minus 2 over y, then my partial y over partial y. Okay, so once you get to this place, the next thing you do is you say let everything here be equal to a constant k. So let it be equal to a constant k. So if it's equal to a constant, you say let that 3 over x partial x is equal to minus 2 over y partial y over partial y be equal to k, okay, or be equivalent to k. So that means that the first one is equal to k and the second one is equal to k. So now this is called Euler's method of separating variables. So that means we are going to separate each of them and then find our x, find our y, and then come back and put it here, and that becomes our answer. As simple as that. Okay, so we separate them. Remember what we did. We assume, we say let u be equal to this. Then we now differentiate with respect to u, so with respect to x and with respect to y. Substitute it in the equation, separate them. After separating them, equate them to k. If you equate them to k, then solve them separately. Solve them separately. Okay, if you solve them separately, then you get your x and your y and come back and put it here. You are done. So we have what? We have 3 over x dx over dx is equal to k. And then we have minus 2 over y dy over what? Dy is equal to k again. So by separation, this one will go here. So I have 3 over capital letter X dx is equal to what? K dx. And then this one I'm going to have minus 2 over capital letter Y partial y. Sorry, all these things is partial, sorry, not complete. Partial. Okay, so partial y, partial capital letter Y is equal to k partial y, like this. So if you integrate both sides, you now take the integral of both sides. So the integral of 3 over x partial x will now be equal to the integral of k partial x. Then the integral of minus 2 over y partial y is equal to the integral of k partial y. Okay, so permit me to clean this side. Remember what we assume to be our solution. So now the integration of 3 over this will give you 3 ln x. 3 ln capital letter x is equal to the integration of this will give you what? Kx. Kx plus a constant. Okay, so now divide both sides by 3. So to have that this is ln x is equal to what? K over 3x plus c over 3. Let me call it c1. c1 over 3. Okay, so but we will now have that what? X now will now be what? Exponential k over 3x plus c1 over 3. So if I separate, I'm going to have that my x will now be what? Exponential k over 3x multiplied by exponential c1 over 3. Now, exponential c1 is a constant, 3 is a constant. Exponential of a constant is a constant. So let me call it a particular constant, a. So therefore, my x now will now be equal to what? A exponential k over 3x. I call this one a. A times this will give you this. Okay? So we have gotten our x. So to get our y, the same method again. So this is going to give us minus 2 ln capital letter y is equal to what? Ky plus a constant. So divide both sides by minus 2. So I'm going to have that ln capital letter y will now be what? Minus k over 2y, then minus c2 over 2. So if I take the exponential of both sides, I'm going to have my capital letter y will now be equal to exponential minus k over 2y minus c2 over 2. So separate it according to your indices. So I'm going to have that my y will now be exponential minus ky over 2, okay, multiplied by exponential minus c2 over 2. So exponential of a constant is another constant. So I have that my y will now be what? B exponential minus k over 2y. So we will now know that our u is equal to x of x multiplied by y of y. So which will give us what? A exponential k over 3x multiplied by b exponential minus k over 2y. So according to indices, if the base are the same thing, we should add the power. So I'm going to have a multiplied by b, the constant. A multiplied by b is ab. So I'm going to have exponential k over 3x minus k over 2y. Okay? So now, the product of two constants is another constant. So let me call it capital letter C. So the product of two constants is another constant. So 2 times 3 is 6, another constant. So therefore, my u, which is a function of x and y, will now be equal to what? C exponential. They have k in common. So I'm going to have x over 3 minus y over 2. They all have k in common. So that is just the solution. As simple as that. So we'll take the next question. I hope this is not difficult. Okay, so this is Euler's method of separating variables. Euler's method of separating variables is very easy. Okay, so we keep moving. Let me review my marker and solve the next question. Question number 2. Right? So question number 2 said we should solve partial u over partial x is equal to 2 partial u over partial t plus u. Okay? Now, this one is very simple, and they gave us a condition that u of x comma 0 is equal to 6 exponential minus 3x. Okay? Solution. This is a boundary problem. So you get the solution, then put your boundary, you are good to go. So remember, the method does not change. You will say, let what? The method does not say, you will say what? Let u of x and y be equal to what? We have x, so it will now be what? X of x, if you like. Okay, let's say of x. Multiplied by, we have t, so it's going to be t of t. Like this. Very simple. Okay? So the next thing is to differentiate with respect to x and with respect to y, partially. So to differentiate this one, I'm going to have partial u, partial x will now be, this becomes a constant. So this one will now be, leave the constant, that is t. Then you have partial x, like this. So differentiate with respect to t. You now have partial u, partial t will now be equal to, this becomes a constant, so you leave it. Differentiate this one, you have what? Partial t over partial t. So the next thing is now to put them in the equation. We are good to go. So to put them in the equation, we have this one as what? As this. So I'm going to have t partial x over partial x is equal to 2x partial t over partial t plus my u is xt. So xt. All this thing means a function, so we don't really need it. You just know that they are functions of x and function of y. Okay? So now the next thing we are going to do is to separate them. How do we separate them? We multiply everybody by xt so that all the x will be at once. Sorry, divide everybody by xt. So if I divide everybody by xt, divide this by xt, so t take care of t, I'm having 1 over x is remaining here. So partial x over partial x is equal to, so 2 over t will remain here. So I have partial t over partial t is equal to, this one is 1, sorry, plus 1. Okay? So the next thing is to equate them to a constant. So if you equate them to a constant, then you separate them, solve them individually, you put back. Very simple. Does not change. So you have what? 1 over x. You can say let 1 over x partial t be equal to 2 over t partial t plus 1 be equivalent to what? K. So let us separate. To separate them, this will now be equal to k and this one will be equal to k. So I'll have 1 over x partial t is equal to k, and 2 over t partial, sorry, how do I get partial s partial t? Sorry, partial s partial x. Okay, so partial t plus 1 is equal to k. So separating them, this one will go here to have that 1 over x partial x is equal to what? K partial x. So this one will go here to have 2 over t partial t is equal to what? This one going here, I'm going to have k minus 1 all multiplied by partial t. Okay, so this one will move here first, then this one will still go there to multiply them. So now take the integral of both sides. So we have the integral of 1 over x partial x is equal to the integral of k partial x. So we have the integral of 2 over t partial t is equal to the integral of k minus 1 partial t. Okay, so this one now is giving us ln x is equal to, this one is giving us kx. This one is giving us 2 ln t. And this one is giving us k minus 1 bracket t. Like this, then plus a constant. Don't forget here plus a constant here. Okay? So take exponential of both sides to have that your x becomes exponential kx plus c. Let's call it c1. And then this one c2. Okay? And then this one will now be your, divide both sides by 2. If you divide both sides by 2, you're going to have that here is now ln t is equal to k minus 1 over 2t, then plus c2 over 2. So take exponential of both sides to have that your t here becomes exponential k minus 1 over 2 all bracket t, okay, then plus c2 over 2. So here, separate this side to have that your x becomes exponential kx multiplied by exponential c1. And then your t becomes exponential, let me call it t over 2 in bracket of k minus 1, then multiply by exponential c2 over 2. And the exponential of a constant is a constant. So I'm having that my solution becomes, so my x becomes, exponential of a constant is another constant. So I have a exponential kx. Okay. Then my t becomes b exponential t over 2 in bracket of k minus 1. So remember that my u of x and t is equal to x multiplied by t. So which is going to be what? A u of x and t will now be equal to what? A exponential kx multiplied by what? B exponential what? T over 2 in bracket of k minus 1. So now, but according to our indices, if the base are the same thing, we should add the power. So therefore, my u of x comma y will now be equal to what? A times b. A times, in fact, multiplication of two constants will give you just another constant of exponential what? Kx plus t over 2 in bracket of k minus 1. Okay? So this is the general solution. So if we now put in the boundary condition, that is given. So the condition that was given is that u of x and 0 is equal to 6 exponential minus 3x. Okay? So now, so what do we now do? Obviously, so that means when u is equal to this, our y is 0. Okay? So and s remain the way it is. So substitute this here to have 6 exponential minus 3x is equal to what? C exponential kx. Remember that our t is 0, not y. Sorry, t. So if t is 0, it makes everybody here to be 0. So I'm left with just these two things. So if you compare this, you see that your c is equal to 6, and then your k is equal to minus 3. So if you compare the two of them, so put this now back into the equation to have that my u of x and t will now be equal to c is what? 6 exponential. My k is minus 3. So I have minus 3x plus t over 2 into my k is minus 3 again. Minus 3 minus 1 will give you minus 4. So if you put the minus 4 here, so this into this will give you minus 2. So everything here becomes minus 2t. Okay? So as simple as that. So that becomes the particular solution to that question. So we solve the next one. Question number 3. Or let's now look into the application of this partial differential equation. You know that you can apply partial differential equation in wave equation, heat equation, and then Laplace equation. So let us look at the application, then use the same Euler's method of separating variable to solve them. Okay, before we now move into another type of solution. Okay, so application of application of partial differential equation. Application. So I thought that in the application of partial differential equation, we have the wave equation. Another one we have is the heat equation. Another one we have is now the Laplace equation. So we're going to start with the first one, which is what? The wave equation. So for the wave equation, let's take an example. For the wave equation, so they say we should solve question number 1 here. Say we should solve partial squared y over partial t squared is equal to c squared partial squared y over partial x squared. Okay. Now, the same method again, the same method of separating variable. So what do? We have t and x. Sorry, my mic went off, so I don't know where the mic went off, but I discovered that I did not put the T that was here, okay, there. So that was I did. That's what I did. We are just trying to put back this, substituting. That is what we're doing. So this thing here is this one. So instead of putting it, I put this as this is equal to your C is this. So this one here is everything here. That is T, the this. So that is T, the this. Okay. So the next thing is to separate. Let all the T be on one side and all the X to be on one side. So the T will come down here and then the X will go down here. So, and the next thing you now say, let that equation be equal to minus K. So I didn't want to do the next step. So we're supposed to let it be equivalent to minus K. Then after that, you now separate them and solve them separately. The first one should be equal to the minus K squared. And then the second one should be equal to the minus K squared. And I told you the reason we are using minus K squared, and so that we'll get the answer in trigonometry. If you use K, you will still get the answer, but your answer will be in exponential form, which if you change it using what's it called, a complex variable. You remember complex variable now, and you will still get back to the trigonometric form, so it will be longer. So use minus K squared to make it shorter for you. Okay, so this is partial squared x over partial x squared is equal to minus K squared. So let us now solve this. Now we are not going to do variable separable because this is not first order. This is second order. So we are going to solve it by second order. So here multiply both sides by t to have partial squared t over partial t squared will now be equal to minus K squared t. Okay, and then for this side multiply by x over c squared. So I just want everybody here to go back here. So if you are down, you go up. If you are up, you come down. So I'm going to have partial squared x over partial x squared will now be equal to minus K squared over x. No, minus K squared x minus K squared x over c squared. Okay, so permit me to just clean here. So now to solve it, I'm going to have that this one will now come here to have partial squared t over what? Partial t squared plus K squared t is equal to 0. And then this one coming here, I'm going to have partial squared x over partial x squared plus K squared over c squared x is equal to 0. So let us now get the what is it called, the homogeneous part. So the homogeneous part here, or the auxiliary equation of the first one will give you m squared plus k squared is equal to 0. So for the second one will give you m squared, or let me use n squared plus k squared over c squared is equal to 0. So this one moving here to have that m squared will now be equal to minus k squared. So therefore my m will now be plus or minus ki. Plus or minus ki. So the equation becomes t is equal to what? For the fact it has I, so it's going to be cos t plus, sorry, a cos t plus b sin t. Okay, a cos t plus b sin t. Right? Okay, sorry. Kt. There is K. Kt. Should be Kt. Kt. Okay? So the same thing is applicable here. So your n squared is going to be minus K squared over C squared. So therefore my n becomes plus or minus of K over Ci. Because if you take the square root of a negative number, I will come in. So that is that. So the solution there becomes x is equal to what? A cos K over Ct, then plus B sine K over Ct. Okay? So now, the solution now becomes to just multiply the two of them. So don't forget that our solution y, is it y that we are using? Where is that? Okay, yes, y. Our solution y is equal to what? X multiplied by t. So which will give you x, which is what? A cos kt plus B sin kt multiplied by A cos k over ct plus B sin k over ct. Okay, so that becomes the general solution to that wave equation. So let's take another example. All right, I hope you are getting it. If you are not getting it, you can rewind the video and watch it 10 times. Yes. Okay, so now the next question uh, we have another question to answer. Okay, let's just solve one more question and then we are good to go. Then in our next video, we'll now talk about heat equation and then wave equation. Okay, so we have 1 minute. Okay, so the next question we are going to solve said question number 2. We should solve partial squared u over partial x partial t to be equal to exponential minus t cos x. Okay, so the same Euler's method of separating variable is what we are going to use. I told you that solution. So we're going to say that u will now be equal to what? X, that is a function of x, multiplied by what? T, that is a function of t. So let us differentiate with respect to x. Partial u, partial x will now be equal to, this is a constant, leave the constant, differentiate this, you have partial x. Okay, so now differentiate again to have a partial u. I think I'm making mistakes somewhere. 1 minute. Okay, so let's take the second derivative with now respect to x, because we want to get this and then substitute. So I'm going to have that this is partial, differentiate this one now with respect to x. Partial squared u over partial x partial t is equal to, now this is product rule, so you leave the first one, differentiate the second one, then you leave the second one, differentiate the first one. So if I leave the first one, t, differentiate a function of x with respect to t, it gives you 0, plus, now leave the second one, which is partial x, differentiate this first one, you're going to have partial t over partial t. Okay, partial t over partial t. So now substitute here. If I substitute here, I'm going to be having, this one, which is what? Partial x over partial x, then partial t over partial t is equal to what? Exponential minus t, then cos x. Okay, so now we want to separate. To separate this now, we are going to have, I want to separate it. So to separate it, we are going to have, okay, let this t come down here, and then this one move to this side. Yes. Yes. So I'm going to have this one coming down. I'm going to have 1 over exponential minus t dt over, partial t over partial t is equal to what? This one will go up, this one come down. So partial x over partial x, then cos x. Okay, remember that after separating, you now say let them be equal to what? K, and then you now solve individually. So I now have that what? Minus 1 over, in fact, minus 1 over this will just give you exponential t. So partial t over partial t is equal to what? K. Okay, then I'm going to have here partial x over partial x, then cos x, is equal to what? K. Okay, so now I will now separate again. To separate, I'm going to have that this one we move to this side. So I have exponential t partial t is equal to okay, is equal to what? Is equal to k partial t. So this one will still come down here to have partial t is equal to k over exponential t partial t, like this. So this one will go here, this one will come down here to have cos x over k partial x is equal to partial x, like this. So let us now integrate both sides. If I integrate this side, I will integrate this side. So integration of this side will give us just t is equal to integrating exponential. For this is taken as the integral of k exponential minus t dt. So which will give you minus k exponential minus t. Okay? Plus a constant c1. Plus a constant c1. So in this particular one, I'm going to have that integrate both sides again. Integration of this side will give you just x, while the integration of cos will give you sine. So I have 1 over k again, sine x, then plus c2. So my answer just becomes the combination of the two of them. So if I combine the two of them, I'm going to have, if I combine the two of them, I'm going to have, what am I going to have now? Yes, if I combine the two of them, I'm going to have that my u is equal to xt. So which is what? My x is 1 over k sine x plus c1, okay, multiplied by then minus k exponential minus t plus c2, okay. So this is c2 and this is c1. So, and that becomes the general solution to this particular problem. Okay, so thank you very much for watching this one. In the next video, we'll now talk about heat equation and then Laplace equation. Bye-bye.